So good evening, everyone. Can you hear me? Hello.
Yes.
Yes, yes.
Okay. Okay. So just we're waiting 1 or 2 minutes for joining all of those other participants. Then we'll start. Okay. So now we'll start today's session. So basically today I will try to discuss about that change detection using Google Earth Engine platform. It can be land use land cover change detection, or it can be NDVI change detection, or any change detection. How we can easily perform using the Google Earth Engine platform. As well as I will try to discuss about that hyperparameter turning. Mainly, it is a random forest. How we can easily find out the best decision number trees to get the better accuracy. Okay, so let's go. Just I simply share my screen and then start. Okay, okay, okay. Okay, so basically this is the process to find out the hyperparameter turning and find out the best number of trees. Okay. So now I talk about that how we can easily make the change detection. Okay, suppose land use land cover change detection or NDVI change detection, how we can easily do. In this time, here you can see here I already make this map. Basically, it show the 2 decade land use land cover map. I already create from the Landsat imagery. Here you can see one map is the year of 2021, and another map is the 1991. Okay, so this is the 1991 land use land cover classification map. Mainly it classified the mainly it's the urban, then vegetation, water body, and barren land. Okay, so here you can get this type of things. This is the land use land cover map 1981, and this is the map for 2021. Okay, so now I want to find out the mainly change detection. Okay, so what's the change, how many area will be changed. Okay, this type of things how we can easily do using the Google Earth Engine platform. I will try to discuss about that. Okay, so here you can see I already make the land use land cover classification map. Okay, 2 decade. So now I want to find out the change detection. So for doing these things, okay, in this time, suppose I want to find out the single class change. Suppose you want to show only for the urban change area. Sometime you also need for the only for the water body change area or vegetation change area, anything. Okay, so in this time I will show you that how we can easily find out the single class change area, how we can easily find out and also calculated the area, how much area will be changed, how much area will be increased. Suppose I want to show you that a single class, suppose urban, okay, how much urban area change, okay. So in this time, suppose I will write the comment single class urban, okay. Okay. In this time, first of all, I want to calculate suppose urban area. Okay, we already discussed about that, how we can easily calculate the area. Mainly, if you want, you can also use the chart, or if you want, you can also randomly you can easily calculate the area. Suppose in this time, from this map, I want to calculate the urban area for 1991 or 2021. Okay, how much urban area in 2021 I want to calculate. Okay, very easy. Just you can take a variable. Suppose I put the variable name is that was build up area, suppose 2021. Okay, just take this variable, and first of all I need to make the build up area map. Okay, so for creating the build up area map, I need to call the full land use land cover classification map for 2021. Okay, so here you can see the map 2021. So you can see this is the map 2021. Okay, so this variable stored this map. Okay, this variable stored this land use land cover map of 2021. So just I simply copy this variable name and paste here. Okay, and then set equal to class number. Okay, in this time, what is the class number for urban or build up? So here you can easily check it from here. Suppose build up area, click on here. Here you can see class value is the 1. Okay, so just I use here the 1. It's the class number for urban or build up. So just use here the 1. And further, I want to display this result. So just use here map dot that layer and call this build up area and paste here. And then just make the visualization. So mean 0. Suppose next 1. And set the color plated. Suppose where there is no urban, I want to show as a gray color, and where is the urban, I want to show as a red color. Okay, and also show the layer name. Suppose urban 2021. So okay, it's the comma sign. And now further use the comma sign. So now click to run. In this one you can see it display the urban year of 2021. Okay. Okay, so here you can see display this result. Here we can get mainly this type of red color pixel identify about the urban area in year of 2021 for this study area. We can get that. Okay. So in this time, suppose I want to calculate it that how much urban area in 2021. I want to calculate for this how much area is available. For doing this thing, just take a variable. Suppose urban area and call these things because it stored that. Simply copy and paste here and use a function dot image dot pixel area. Basically this function calculated the pixel area in square meter unit. So now I want to calculate this value. For that, just take a variable. Suppose I put the variable is the area. Suppose urban area or area urban. Suppose 201 area of 2021. So now call this thing from here urban area and paste here and use the function reduce region. This function calculated that pixel, it can be maximum, minimum, total, or any statistical value. When you need for the specific boundary, then we are use this reduce region function. And then I put all of those argument one by one. So just make a dictionary. So curly bracket start and also curly bracket int. Okay. So now further reducer. In this time I want to calculate the total area. So just use that dot sum total area of urban. Geometry mainly it's your specific boundary. It's I check what's the name about that. This boundary name is that AOI. So just put here AOI. 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 Scale is the resolution, mainly Landsat 30-meter resolution. And other things not here, I simply remove that. Then simply print these things. So just print. Now we can get the urban area in 2021 for this study area. We can see it calculated as a dictionary. Basically reduce region all time. We can get the result as a dictionary. We can get the result in square meter. Suppose I convert in square kilometer. So for that, just use this function. Suppose just take a variable. Suppose urban area 2021 square kilometer. You can put any variable name. And now this is the number. This number I have to convert in square kilometer. So it's a number. So for that we have to use the number object function. It's called dot number. Dot number. And this number is stored in this variable. Simply copy and paste here. Okay. And here you can see this number get from classification. Okay. So simply copy these things and use a function get. Just use here dot get classification, and I want to just use a function divide with 1 6. Okay. Then further I just simply print that. Now we can get this result in square kilometer. Click that. Okay, so now you can get the 74.93 square kilometer area for urban in 2021. Okay, if you need the round figure, so just use a function, suppose round. Okay, then we can get only for the integer value for the round function. Okay, so in this time we can get this result for year of 2021. Okay, suppose I need this result for 1991. I have to check how many urban area in 1991. Basically this map for our land use land cover year of 1991. So this map I want to find out how much area of urban or build up. In this time, I want to check it. So for doing these things, just use the same code, simply copy from here, just simply change the variable name. Okay, so in this time I just write the code for calculating the area in 1991 urban area. Okay, just paste here. Okay, so in this time I simply change the variable name, suppose build up area 1991. Okay, and also call this variable name about this variable land use land cover map variable name. Okay, so this variable name you can simply get it from here. You can see yeah, so this is the variable name, classified rf 1991. Simply copy and further use it in here, paste. Okay, then you can check about the build up area. So simply click on it, you can check about the value, same value 1. So just put here that 1. Okay, then simply copy these things from here and paste here. Yes, so this same thing, just simply change the layer name, suppose it's a 1991. So just put here that, and then further I do this calculated the area, suppose just simply copy and paste here, and further I want to calculate, suppose it here just 1991. Okay, the same, no problem, urban area, no problem. And then further copy and paste here, and to calculate it this square kilometer, just use this change variable. Suppose I put here that 1991 square kilometer, simply copy these things and paste here, and then further simply copy and paste here. Okay, so now click to the run. In this time we can get this result for 1981. What is the condition or how much area for urban or build up, and also calculated the area, and also display this map about the urban map in 1981. You can see it also show the layer urban in 1981. Okay, you can see it show the map. You can see we can get, yeah, so here you can see we can get the urban area in 2021 in 75 square kilometer, and we can get the urban area in 1981. We can get the 5 square kilometer. So this it show the basically this map show for the urban map in 1991. We can get the only for the 5 square kilometer area, but in 2021 we can get this 75 square kilometer. So it's increasing this urban area. You can see we can get the increase of 70 square kilometer area increase for this urban. Okay, so we can see it increase. Okay, so now I want to make the change detection. Suppose single class change detection. Suppose how much, suppose in this time we find out this area change detection mainly mainly urban area in 1981 and 2021. So this time period, how much area will be changed. Okay, we can get the statistical value already. In this time we show this result on the map, mainly change detection map. Okay, for doing these things, for calculating the change detection map, just take a variable. Suppose I want to show the change detection map. Let's take a variable, suppose urban changed. So now in this time, for the change map, first of all you have to call the before class and after class. So in this time, before class mainly 2021 and after class in 1991. Okay, and I already make this map for the before class and after class. So basically you can see this is that it's a before class 2021 and after class 1991. Okay, so in this time we'll just make the subtract between this before class and after class and then find out these things. First I call build up area is build up area 2021, simply copy after class and paste here. It's after class, subtract with before class. So just use a function before class, mainly it is at 991. So copy, paste. Okay, now show this layer. Just take a variable, carbon change map, simply copy and paste here. We'll show the result. Suppose mean show 0 and max suppose 1. Let it make the list. Suppose I put the YOLO and red color. Time this map show the changed and unchanged of urban area between this time period year of 1991 to 2021. Okay, changed and unchanged of urban area. So in this time where there is no change, it show the yellow color, and where there is change, it show the red color. Okay, so where there is no change, suppose in this time you can see this area it's already show the urban. Okay, so this area is not changed, and when I show the map for 2021, it is still about suppose you can see only focus this place, you can see it is still show the urban. Okay, okay, you can see it is still show the urban, so there is no change for this type of red color pixel is not changed. Okay, so it's the unchanged area, but this type of other place here you can see in the this type of place it also set up new urban. Okay, so it's unchanged area. So now click and check about the, I also put the layer name. Suppose it's a change map between this time period year of 2000 urban changed. Does it show this result? Okay. So here you can see this type of yellow color. Okay, so this type of yellow color identify about that no changed. Okay, and this type of red color identify about the changed area. Okay, suppose in 1991 there is no urban. In 1991 there is no urban, but in 2021 we can get this type of place is urban. Okay, It's called the changed area. But in this time here you can see this region it also show about that yellow color, because there is no change. It is still in 1981 we also get this urban, and present 2021 we also get the same urban, so there is no change. So that's why in this time we can get this type of things. You can see it also show about the yellow color because it not changed, it only show the changed and unchanged. Suppose this type of yellow color it show the unchanged area, but this type of red color identify about the changed area. Okay, so basically it's called the single class change map. If you want you can also do for the water body or vegetation or anything. Okay, so I will show you the example for the urban. Okay, in between the two time period urban we take, and then make this change detection. This type of change detection you can easily create from here. Okay, in this time I want to show all of those class, not only for the single class. So in this time it show only for the single class, only for the urban, but I want to display the result for all of those classes, mainly water, build up, vegetation, and barrel land. So all of those classes, then make the change detection and also calculated the area, how much area will be increasing about that. These type of things it's called the transition area. How we can easily calculate using the Google Earth Engine platform. In this time I talk about that. But this is the process you can also apply for the single class. Suppose urban or vegetation or any single class, you want to make the change detection map and also calculate the area. So for the single class, same process for any. In this time I talk about the multiple class at the same time. Change detection. Okay, so in this time when you want to use this multiple class change detection, so first of all you have to make the reclassify. Okay, in this time first step you have to do reclassify. Okay, I also write the step. Suppose step 1, you just make the reclassify from, suppose reclassify 0, and you can see in this time for that it will be step from 0, then 1, 2, 3. Okay, so 0 to 3 reclassify into 1 to 4. Okay, first step we need to reclassify. Suppose it will be 0, then 1, then 2, then 3 we put, but in this time I reclassify it into 1, 2, 3 and 4. So water will be 1, build up will be 2, vegetation 3, and others mainly barren land it will be 4. And also do for the 2021 also, water 1, then build up 2, it's 3 and 4. Okay, so first step we make the reclassify. So how I can reclassify? Very easy, just take a variable. Suppose I take a variable, suppose before class, you can put any variable name. Before class mainly 1981. So in this time I call this before class land use land cover map, basically 1991. So this map, okay, land use land cover map 1991, I need to call and reclassify this level. So for doing this thing I simply copy this variable name from here. Where is it? This is the, you can see, simply copy, and now I want to reclassify it. So simply paste here. For reclassify we use a function, this function called the remap. This function help you to reclassify, and now I want to put here the reclassify mainly in this time just put here the value, my previous value 0, 1, 2 and 3. Okay, and now this value I have to turn into 1, then 2. Okay, so this value 0, 1, 2, 3 I want to remap, mainly reclassify into 1, 2, 3 and 4. So now water will be 1, build up will be 2, vegetation 3 and others mainly barren land will be 4. So it will be, okay, just let me check, this variable name is that, yeah, this simply land use land cover map you call and then paste here. So now you can see this is my before class mainly 90 191. Okay. So just put here 1991. Okay, just use the same variable name. This variable just use this map variable name. Suppose land use land cover map variable. So this variable name you can easily find out from here. You can see this is the layer name LULC 991. You can simply suppose control and F. You can simply search control F. You can see control F, it will come, and you can simply write here. Suppose LULC suppose 9091. You can see it automatically find out this layer name. Simply copy. Okay, so it's another name. I think we have used the 2 times. So now try to find out. Just simply click on here. I think some mistake in here. Just let me check. Okay, so okay, it's mistake. So in this time, I want to add this map. Okay, so further I have to use this function. Simply copy. This is the name here. Okay, so now it will be okay. So you can see this the name. So just use the same name in here. Okay, so now it's okay. So you can simply search the layer name and then simply copy this variable name, and then you can easily find out this land use land cover map variable name. Basically, this variable is stored this land use land cover map. So just use here. Just use here in here, and then remap this class. Suppose 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Same things for that after class, mainly 2021. So simply paste here. I just change the variable name, suppose class, and call this variable name. So I can simply search here. You can see this layer name is that 2021 LULC 2021. Basically this map. I simply search here LULC 2021. So here you can see this is the layer name. Just simply copy this variable. Okay, then just use it in here. Just use it in here. Okay, so now we reclassify. Mainly 0 will be 1, 1 will be 2, 2 will be 3, and 3 will be 4. So now 1 is water body, 2 is build up, 3 is vegetation, 4 is others or build up area or sorry barren land. Okay, so this is the first step to reclassify when you need to make the multi-class change detection. Okay, so now you have to calculate a transition area calculation. So in this time, second step, transition area calculation. Okay, for this transition in this time, we have to apply a formula for calculating the transition, mainly water to water, water to vegetation, water to build up area, water to barren land, or this type of things we calculate in this time transition. For doing this thing, just take a variable. Suppose just take a variable. Suppose March. In this variable, I just apply a formula. Basically, this formula is the before class. I already simply copy the before class. Multiply with with 100 and add with after class, mainly these things. Okay. So in this time, it shows the transition area calculation. Okay, so before that, if you want, you can also make the change map. Suppose I want to display the change map. So for doing this thing, just you take a variable. Suppose changed just class. Yeah, okay, so you can see, yeah, so here you can see they are put this type of value VC and TCI. So when you can get the greater than 10, it's the extreme drought condition. Okay, it also includes the SPI also about that. So for this type of thresholding when you want to make the class, just we are use here the hire function. Okay, so hire function and then make this type of class of NDV or BC or TC or other things. Okay, so any question you can ask me. Any question or any doubt? Okay. Okay. So if there is no question, okay. So basically, okay. So as soon as possible, I will put all of those in here for our recorded video class, and also then I put in here in our classroom. Okay, and also further, I also put all of those assignment. Okay, so for that, I think the total 5 assignment I try to put in here. You try to submit it all of those assignment in the Google Classroom, and for the future, when you face any problem regarding any issue, you can easily join my live training, or for you can easily join, no problem, really, regarding this online training program. When you face any problem regarding any issue, suppose sometime you try to work but this code is not work, so then you can easily join with me and also share it with your code, and then I also try to help you to find out the problem and give you the solution. Okay, for the lifetime. Okay, so basically Google Earth Engine platform, it's a continuously learning, otherwise you forget all of those things. So just try to practice, and when you do the practice, you face some problem. Okay, so for that you will also get the lifetime teaching support for any time. You can log me or you can send me your code link when you face the problem, then you can easily get the solution. Okay, sometime if you don't understand about that, you can easily join in my live, and you can easily get solution. Okay. Okay, so any question you can ask me. Okay, any question? And okay, and
Hello.
yeah, please.
Hello. Uh, when do you the problems related to image processing and all queries, doubts?
Okay, so this is it, all time it will be open. So WhatsApp group or also in our Google Classroom. Okay, you can simply contact from here anytime. You can easily you can get the feedback from here.
Okay, okay.
So basically, this is the journey to start the Google Earth Engine. Actually, Google Earth Engine, a lot of remote sensing work we can easily handle, such as mineral exploration, as well as also we can do for the future prediction. Lot of things we can easily do using the Google Earth Engine platform. But in this online training program, I will try to focus mainly in this syllabus. Try to focus. Uh, you can easily understand in this time when you complete this full training session. I hope you can easily understand about the code. Okay, and now in this time you try to read some journal or remote sensing paper, or also some scientific paper about the remote sensing, and try to develop this type of things using Google Earth Engine platform. So it's the best practice for learn the Google Earth Engine platform. So you can see there's a lot of paper or lot of journal. You can see they are only use the ArcMap software or QGIS software or ENVI software. Okay, so this type of things you try to develop using the Google Earth Engine platform. Okay, then it also best to learn with Google Earth Engine platform, and you can easily develop the new algorithm. When you write the code, you read the paper, and this paper you want to convert into the coding. Okay, so then you learn a lot of things from here. Okay, so the best practice you try to read some paper, and this paper you try to develop this code in Google Earth Engine platform. Okay, and further when you face any problem, if you don't understand how we can do that, then I also try to help, no problem. Okay. Okay, so you try to practice, and further face any problem, you can let me know, and also let me know in our WhatsApp group. From that, you can easily get the lifetime training support for regarding this online training program. And not only for that, if you want to invest in the more advanced online training program, such as we are also providing, such as deep learning, machine learning, as well as we are also providing the web mapping, as well as also Google Earth Engine web application develop this type of things. If you want to interest more, then further you can easily join. Okay, and you can easily get all of those information from your WhatsApp group. When you start the any best program, you can easily get the notification in your WhatsApp group. You can get the full syllabus, all of those things you can easily get from here. and further you can easily join for the further more advanced. We are also providing the 15 days Google Earth Engine online training program. So basically, this online training program, we focus for the different types of algorithm from the different types of paper. We focus and then try to develop this type of things in online training program, such as Rusli model, as well as also rainfall analysis, drought monitoring. So these type of things we try to cover the 15 days online training program. And this is the 7 days. So mainly it's the beginners. Okay, mainly start to the journey to the Google Earth Engine platform. Okay, so further if you're interested in the more advanced online training program, you can easily get all of this notification from our WhatsApp group. Yeah, please.
Please share the details about 15 days Google Earth Engine program. I have sent you that message.
Okay, I send you. Okay, so I send you in your group. Okay, about that. Then all of people at the same time they can watch. Okay, no problem. Okay, so basically in this time it not start the registration. So after a few months we will start this registration, and then you can easily join it.
No problem. Please share the details.
Okay, I will share. No problem.
Okay.
Okay, thank you. Okay, thank you. Okay, so thank you for everyone for joining. Okay, thank you.
Thank you.
Okay, have a good day.
Great work done.
Okay,
Thank you.
Okay, bye.